Good morning, everybody. I'd also like to thank you, Fine, for organizing this event. I add my appreciations to yours. And thanks for inviting me and the very kind introduction. We've been interacting for quite a few years now, and the value and enjoyment of the interactions is mutual. So indeed, today I will talk about a line of research that we've been pursuing in the last years in my group, and as well as a newer, actually, line of research that's quite in initial phases, and we'll get into it. But as the title hints, the general idea is, how can we account for users in text generation? And the line we've been pursuing from that perspective, I mean, there may be many aspects in which you need to account for users. We've been focusing on this issue of localization. So the talk will be mostly about that. And then the last part, this new research line, will be about interaction. Okay, so let's start. And of course, first, credit goes to the students involved in these projects and external collaborators. So, from this perspective, when I talk about text generation, I will focus on the aspect of hallucinations, the fact that hallucinations do happen, and we need to do something about them, because when we read information produced by LLMs, we would like to verify. I mean, when we get information from reliable people, usually we trust, we don't check everything, but with LLMs, we can't do it. And here's an example. You can see, here's a question, tennis events in late 2025, and there are two different, let's say, retrieved sources from which the answer could be generated, and the answer was generated. But then there is some, if you read it, you can maybe spot who can spot what the error here is?
So timing.
The time is fine, actually, because it's kind of, but the location, you see, the ATT finals are actually not in New York, right? While the summary kind of merged them together, mixed things, and have located the finals in New York. And by the way, just remember this example that it took you a bit of time to figure out what the hallucination is, right? And then to verify that it's indeed an hallucination, right? That's the whole issue that motivates us, okay? So the kind of assistance you would like from, let's say, from some tools when we cope with LLM-generated output, one is to detect hallucination. It took you a bit. It will be nice if we would have a tool that would immediately direct us at the suspected errors, right? As well as help us to verify the correct information, right? Because for any piece of information in the LLM output, we don't know that it's whether it's correct or hallucination until we verify it. If we succeed to verify, we see that it's correct. Otherwise, we know that it's a hallucination. Okay, so that's a process, right? We are interested, and I present all along the motivation. We'll think of ourselves as user consumers of LLMs, but in a sense, a kind of a theme I'll be mentioning along the talk, that the things that are good for us as human users are also good for many downstream tasks. So often this kind of feedback, like hallucination detection, attribution, could be also useful for downstream tasks, like the LLM itself may get this feedback and improve itself through that, or if you want evaluation measures, okay. So I'm focusing on users, but actually it's good also for automated processes downstream. Okay, is there a clock somewhere that maybe I'll put my phone? Oh, this actually, I see, my screen is not full screen because it's sharing, so I can see the time here, it's fine. Okay, so it's fine. Thanks. Nice. It's too big, it's kind of, stressing to see the, okay, I put it a bit aside. In the background, yeah, okay. Okay, so, that's it. Okay. Okay, so the kind of main claims and goals I would like to put up in this talk are the following. The first is this issue of localization, that was in the title, that both when we detect hallucinations or we give attributions, I would argue that they should be localized. They should focus precisely at the error or precisely at the supporting information. Then later on, I'm going actually to argue that these two tasks of hallucination detection and attribution, which are currently dealt with mostly separately, even though they do get unified in some fact-checking frameworks, they should be seen as a single task and should be unified because basically we as users want it in order to verify what's correct and what's incorrect. Attribution is supposed to help us to verify something is correct. Hallucination detection is supposed to point us what's incorrect, but we need to do both simultaneously. So unifying these two. And the third point is what I mentioned earlier. I won't show results on that, but I want to carry that message all along, that this kind of localization is useful not just for us, but also for an LLM that needs to refine itself. It's better that the feedback the LLM would get would be pointing precisely at the hallucination, not saying something is wrong in this sentence, and then the chances that the generation method would fix it would be lower. Okay, so LLMs also have their attention like us, and it's better to focus them on the right information. So the outline will be, the parts I will actually kind of words I will actually cover. First, I talk about localizing hallucination detection. Then 2 works about localizing attributions. Then I talk about a project that is about unifying them as an entailment reasoning justification. And Yifan mentioned that actually the whole line of entailment that later became known as NLI actually originated from our lab kind of 20 years ago. So it's nice to revisit it now in this context. I'll say a few words about it. And finally, the new line of research that we are getting into, and I'd like to expose and motivate, not showing results yet, it will be mostly showing mock-ups, is about how can we involve the users in a more interactive manner in these generation processes. Okay, so these are the 4 parts I'm going to cover. So the first talk, lead student is Arya Katan, just finished his PhD, moved to Google Research, and collaborators both from Google and from UNC. And Morit Bansal's group, if people know the name. And it's currently an archive paper. I hope it will be published soon. So here's another, this is the running example. In this part, you can see here some report, and we want to generate, in this case, a summary. Okay, this is the example here. Okay, and you can see that the summary has some hallucinations. They are hinted by these other lines or kind of highlights. So some facts are wrong here. Okay. So why is it important at all to detect hallucinations? As I motivated upfront, right? Hallucination is part of the thing you want to detect in NLM output. Evaluation. There has been quite substantial work on developing measures. People that develop generation systems or LLMs often would like to test, how much they hallucinate, and there's quite a line of works in the literature about how to measure, how to evaluate the level of hallucination that an LLM or a model generates. Okay, so evaluation is also important for that. And the feedback that I mentioned before, to be more concrete, and I'm putting up now, but it will be relevant for all parts along the talk. Major parts where automated feedback, like hallucination detection or attributions, could help downstream processes, is in order to improve the factual consistency of models. And this can be done in different ways. So one common way, like if I can point a model, can detect hallucinations as a model, I can do reinforcement learning, and there have been some works on that, that tell the model, here you hallucinated, so you get, a low reward. If you didn't hallucinate, you get high reward. Another method is in self-critiques that models generate, and then they test their output, and then they revise it. There's literature about that as well. And controlled decoding means that actually during the autoregressive generation process, you apply some mechanisms that give you feedback whether you're hallucinating, and then you can correct it. Okay? So these methods that are useful for us as humans can also be integrated very well in known kind of stages in building generation models. Okay, so we have enough motivation. What this work is about, okay, it's not enough to say, like we've seen here, right? That, okay, there's a hallucination somewhere. I mean, usually most data sets won't, I mean, this was just for, I mean, these highlights were just here for the slide, but most data sets will just say, this sentence is not factual, okay, and won't point exactly. And the message this work is about that we need to localize where the hallucination is exactly, okay? Okay, so we want some method, we agree with the motivation. It would be nice if someone would tell us this is exactly the wrong individual fact within the output. So how can we do that? Maybe, and there's some work suggesting, I don't have the reference here, but it suggests the highlighting, like here, okay? Is this good enough? So let's see actually what are the wrong facts here. The wrong facts here in the output is that this man, I mean in the original document if you read, this man died, but it was not clear if he died from measles. The summary said that he died of measles. That's a wrong fact. Okay, that's one hallucination. And the other, there was an examination, but the examination was, here it said that examination failed how he got the illness, but the examination was actually on how he died. Okay, so it's just information, right? Information is always about subtle facts that you can mix up. So these are really the two concrete facts that are wrong. And by just highlighting, you don't really know. Suppose I would highlight died of measles. So what's wrong here? Is it wrong that maybe he didn't die? He had measles but didn't die out of it? Or maybe he died out of something else? It's not localized enough. So if I just highlight, I don't know exactly what the wrong fact is. Okay. And indeed, as I mentioned, so the spans are not localized. Experiments has shown low human inter-annotator agreement of what exactly should be highlighted. Okay, so task is not well specified, and also for the motivation of evaluation, if you would count how much of the text is localized, then again it doesn't correlate well with the overall severity of hallucination that people perceive in particular outputs. Okay, so this doesn't really work. It's not formal enough. Excuse me for a second, just that I don't step on my lace. Okay. So this doesn't work. Another option is to decompose. That's, I mean, if you know, fact score is quite well known work with hundreds of citations. There are some follow-up works along that, and what it does, it takes the output and breaks it into facts. It acts as actually an LLM. You give a prompt an LLM, decompose this sentence into a list of facts, and this is the output obtained from fact score for this sentence. And then you can test, let's say using entailment, NLI, each of them to see whether it's really entailed from the source, whether it's factual relative to the source or not. And you see the X's and the check, and you see that actually most of those end up being wrong, even though only two facts were wrong, because again, these are not atomic again, right? Like for instance, one of them, the man died from measles. You don't know exactly what's wrong here. Okay, so the problem here is that these facts aren't atomic, okay, and they are not systematic. It's not really clear how to break down into facts, okay? Even though this is in the direction, right? What they said, we would like to identify the exact facts that are wrong. So how can we, so in a sense, what we want to do is to maximally localize, right, the pointing at the hallucinations. And here, we suggest revisiting and looking again, like some other, at classical work. You can see the method itself is called Neo-Davidsonian. I put in the citation for, all these, by the way, are clickable. I assume the slides will be online, right, later on. This line of research in semantics, actually, natural language semantics, originated from this work back in '67, almost 60 years ago. And later was evolved to what's called Neo-Davidsonian. So Davidson's method was called Davidsonian decomposition, and then there were some extensions by several researchers that ended up being Neo-Davidsonian, called Neo-Davidsonian. It had a major influence on the evolution of semantics in NLP, in the history of NLP. And the idea is to break the sentence where a man died of measles. It was done in the framework of formal semantics. So the original this original line actually suggests to decompose and represent the decomposition in logic. Okay, and in logic it will be like there exists an event. I assume people can read roughly first order logic, and that was a dying event. So there was a death event, and the agent was a man. So a man died. The cause was measles. The death was because of measles. So if we translate the logic to natural language, it will be these three assertions. Okay, and as you can see, this really the idea here is basically that you maximally localize each fact that you put here, right? Each conjunct here is a statement that can have a truth value. Each of them can be true if it's not hallucinated, or false if it's hallucinated. So the idea is that you kind of maximally localize these facts roughly at the semantic relation level. So this inspired works lines like SRL or AMR, these graph representations in structured semantic representations in NLP, which are now less relevant, but in the history there were these impacts. And as I mentioned, actually quite recently there were several revisits of these neo-Davidsonian graphs. For instance, in verifying that a generated photo, there was work by the group of my collaborator Moit Bansal called Davidsonian scene graphs. If you want to check, I want to draw I don't know, a plant near a window and an air conditioner, checking whether the photo generated indeed includes these facts, and the decomposition there to check that each particular facts specified in the image generation prompt is indeed in the photo was using such neo-Davidsonian decomposition and some mechanism. Okay, but also in recent works, usually people don't go to logic. Logic is hard, is structured. It didn't succeed in the history of NLP. And nowadays, LLMs can work very well with natural language expression. So we don't work with this level, but something that is natural language, like here or another form. Okay. And the line, actually, thanks you, Frank, for mentioning the topics we were discussing, is a line of research where we did something that's inspired by neo-Davidsonian, but the decomposition is not to. These are called affirmative, right? You have interrogative, a question, affirmative, or declarative, and imperative. So instead of stating these as affirmative statements, we state the facts as pairs of a question and answer, right? A man died. A man died is like who died a man, right? It's the answer. It's equivalent semantic. You can phrase a fact as a pair of a question and answer, or stating the question and answer together. So here, there are different motivations for works. These are earlier works from our group. QE norm is for our group. This original method starts from Luc Zettelmoyer's group in the University of Washington, Lu Heng He, in her PhD work 10 years ago. Decomposing a sentence into a set of questions. So what you see here is actually a set of questions that each of them roughly corresponds to a single neo-Davidsonian assertion, okay? And it will be like, who died a man? How did someone die from measles? You can see the man died from measles, is broken here, and so on. Okay, now if you check for these, like using an entailment system, actually entailment systems, like LLMs are actually quite good in, you say, does the source text entail who died a man? It works well. So what's called hypothesis in entailment can be also a question answer pair. So if you test the validity of these, then you indeed find that these two are wrong and all the other are entailed. And these are exactly the two localized hallucinations, right? How did someone die from measles? That's not wrong because the cause of death wasn't known. And why was someone examined to establish how he got the illness? But actually, that's what the summary said. But actually, the source doesn't entail this because in the source it said he was examined to find out how he died, for what did he die, not how he got the illness. Okay. So we can see that this approach, following the neo-Davidsonian tradition, actually does bring us the desired level of decomposition, which is much more minimal. Okay, so the contributions here are, on one hand, maybe this slide. So the two things maybe to take up to this point, and actually just a summary slide of this project. One is appreciate and maybe get yourself acquainted a bit with the Neo-Davidsonian approach, okay? Nowadays translated into natural language decomposition, not in formal logic, but in natural language, because it's really inspiring. You see, it's almost 60 years old kind of a tradition. Neo-Davidsonian maybe evolved a decade later in the 70s, and it's very influential. It seems to be, there seems to be something true or correct in this kind of approach to meaning. And the second thing, maybe you're welcome to have, in my Google Scholar or DBLP page, look at our QA base, because we have like an implementation of that, and it's still ongoing work. We are about to submit now, so works that still keep advancing this. If you would like to test, to try this approach or to better understand it. But the Neo-Davidsonian is more important because there might be different implementations. I invite you to look at ours. Okay, so to sum up, the contributions here is one, this approach of trying to localize with QAs using this Neo-Davidsonian styles QAs. And by the way, a collaborator, a student of Moed Mansal, Yue Zhang, now is going to publish, we are also co-authors with collaboration, a paper on column of another use of this QA decomposition for actually summary quality evaluation, not for faithfulness, but for summary quality. So that's the approach. So this approach generates twice the number of facts than fact score. Okay, so indeed it's more granular. We also, along this work, we also generated the first entailment data set for this QA hypothesis. So actually, you can set up such a data set if it's useful for something. A data set where the hypotheses are not affirmative statements, but are rather question-answer pairs, and the question whether the question and the answer are entailed by the reference or by the premise. And it's a diverse data set of different sources. When you apply these, like if you give a measure that says, like in this case, it's, the hallucination level is 2 out of 6, okay, because we have 2 X's and 6 statements. This measure correlates better with human preference. So if you give people 2 outputs and ask which one hallucinates more, 2 different systems, and you get human judgments, just qualitative judgments, I see more severe hallucinations or more hallucinations here than there. And you apply our measure and count how many X's there out of all the X's by our decomposition, you get high correlation, better than other methods with kind of subjective human judgments. And there's still, of course, a large room for improvement. One thing to mention is that in this work, the kind of questions only revolve around verbal predicate and verbal normalization. So someone acquired or whether there was acquisition, like died or death, okay? But not other things like adjectives or discourse relations. And there are extensions we are working on, and there's still room for improvement. So those are the work, and I think maybe you got the flavor of what we are aiming at when we want to localize, saying exactly which pieces of information are incorrect. These are the only ones that need to fix, other things are fine. So now I'd like to move to the other line of research, right, about attribution. Attribution is about, here's the output, system output, and I tell you what implies it, what supports it in some reference source. If it's summarization, it should be supported by the summarized document. If it's, let's say, a reg, right, like a retrieval augmented generation, it should be supported by the retrieved snippets. If it's just a statement produced out of the model parameters, then it should be supported by some reliable evidence that we, again, retrieve post hoc. But we also always want to show some supporting evidence in some relevant source that would entail or imply the LLM output. That's how we would allow users to verify that the output is indeed correct, right? The first work I'm showing suggests that indeed we should show these attributions in a localized manner, and I'll say in a minute what we mean here. So here is an example taken from the data set of ALK. ALK is a famous attribution method, a citation method. And you see there is a question right at the front. There is the output of the model, and the model gives attributions. Okay, it actually points at the documents from which this answer was, on which this answer relies. Okay, so this is the ALK. You can say again, quite highly cited work. And for each sentence, it cites at the sentence level. For each sentence, you have the citations telling in which documents the supporting information exists. However, I mean, the story looks nice, but however, what does each such link mean? A whole document, right? And now you want to verify, the first sentence. You need to start reading across all these 3 documents to figure out where really is the information supports the individual first sentence. And for the second sentence, you have to go through 2 documents, right? It's very tedious, okay, and error prone, right? Which makes actually current mode of full document or even passage level citations quite useless. I mean, people don't do that, it's just too much work, right? So what we suggest is actually what we would really like to have. It's quite obvious, right? We would like just to have, instead of sending us to the full first document, just send us to this 1A, where in the document the parts of the first sentence are supported, and similarly in the second and third, right? And the B's would be where the second sentence is supported. So if you produce such data, you can easily imagine like an interface, a UI, that would allow a user, to click on a sentence and just get the relevant highlights, much shorter spans than starting to search through long documents. So that's where we want to get. So how do we do that? In this particular work, this attribute first paper, it was presented in last ACL. The idea was to do the entire generation driven by the attribution. So instead of typical method that either generate the output and the citation simultaneously, or typical methods do one of 2 things. Most methods, I mean, we are not the only one in the method that I'll present, but they either do simultaneous generation. So they ask the method to generate, like here, that's how ALK actually works, okay? So ALK would generate simultaneously both the text and these 1, 2, 3 or 2, 3, okay? So it's nice, but there's nothing that really guarantees that these 1, 2, 3 or 2, 3 indeed support the sentence. They were just generated of the output, okay? So nothing in the process that guaranteed that or even directed there other than relying on the LLM's kind of logic that when you tell it, please tell where on which parts in the source this sentence relies, it will understand our instruction well and match it, right? Or the other method, so that's ALK. The other method is just to do it in post-processing. So first you let the model generate, and then you search for where matches for the sentence in the sources, and you point back to that. So the first method I mentioned is called self-citation, you do it simultaneously. And the second I mentioned is called post-citation. Okay, you just first generate, then attribute. What we propose in this work is to do it the other way around. First, let's choose the attributions, because we get the question, so we can do something that is like extractive question answering or extractive summarization. Let's see which parts in the source should really get into the answer. Let's first highlight them and then generate accordingly the answer. And then the whole process drives the model to stick to the correct attributions. Okay. So how does that look? Okay, we have that. So first step, we select the content. So here basically we do kind of like extractive question answering or extractive summarization. Then we plan the answer. So here, right, to answer the question in full, we needed here, like, how many, like, you have here 5, right, 5 spans. Or sorry, 7 spans. Okay, it's too long for one sentence. So let's plan how we package this information that we want to give in the answer into, in this case, 2 sentences. So the next step is sentence planning. Okay, so you say, okay, these would go into the first sentence and these to the second sentence. And now, after we've decided which information should go into which sentence, we can start generation. So when we generate the first sentence, we only give it, this is purple kind of, I'm a little bit, miss some colors. Purple, right? Yeah. So the first one should be the purple. it always breaks the ice when I share this, when I struggle. Okay, we only need to generate the first sentence. So I only give the model as input these spans in context. So I also show the context, but I tell it generate only from the purples. And then when I want to generate the second sentence, again, I show it only this color, but I also show it the first sentence I generated. So the second generation could be generated in context, like you'd like to have coreference or some kind of discourse flow. It sees the first sentence when it generates the second, and so on. Okay, so that's basically the method. Okay, and then we get what we wanted. It's also easily verifiable. Notice that if there is a hallucination, it's easy to check it, right? Because the model was instructed to generate the first sentence just from the purples. So now to verify whether the first sentence is by design hallucinated or not, I don't need to start checking the entire 3 documents. I only need to check the 3 sentences. If it's not stemming from that, then the model did something wrong. Maybe it managed to somehow generate something that appears elsewhere in the document, but that would be, mere chance and very unlikely. So it makes also verification much easier, okay, much more focused. Okay, so this is the attribute first approach, and some results. You get citations that are like 45 times shorter than the ACT because you don't point. I mean, that's what you would expect because I just pointed full documents. And in a user study, it took annotators about half the time to verify because they were just directed to the right place. They didn't have to do all these Control F to search for where the information is or to read the entire documents. Okay, so we've also seen in prior work that it can also help reducing the amount of hallucinations. That was in another study. It makes sense if you give models a rather short context to generate from, the chance of hallucination of mixing up facts from the input that appear elsewhere in the inputs and are not related, like the New York hosts the ATP, this other tournament that's not in New York, is lower because they get a short context to generate from. Okay, so this is the idea of the first work on attribution, localizing in the source, right? You said the attribution should be localized. This second work is kind of a follow-up work by Eran Hirsch. This will be presented next week in Vienna. I think it's on Monday, so you're welcome to check the program and come. I think it's late morning to come to the poster session. Eran will be presenting it. If someone is interested, welcome to look for him or to send him an email. And here the idea is to complete the story, this localization story, by saying that we want to localize not only in the inputs, but also in the outputs. In the outputs, we saw that the traditional way was to put all the citations at the end of the sentence. But sentences are long. They have multiple facts. What if I just want to verify one of them? Why should I start struggling with an entire long sentence? Sentences usually have quite a few, 3, 4 different facts. Okay, so that's a contribution of the second one. Okay, so this is what we've seen pretty much like in attribute first in the previous work, right? Like we have citations at the end of the sentence, and these are the citations localized in the input. But what happens if I only want to verify this fact, that they deserve to know, they have the right to know, to know what they are eating in the output. I only want this fact, the yellow fact, to verify. I don't need basically to look at all the rest, right? And even if by the way, if I would like to verify the entire sentence, it will be much easier for me to do it fact by fact and not get at once all the citations for all the facts in the sentence. Okay, because sentences are also complex. So that's what we would like to do. And in this work, we actually investigate a setting where the user decides what they want, what they want to check. So if they want to check that fact about they deserve to know what they're eating, they would just highlight it, send the query and get the attribution only for what they highlighted. Okay. And of course, that should go along with the localization of the source. The attribution of the source should be as before, just the relevant span in the source and nothing more. Okay. And this puts up another issue that we'll discuss in a minute through the example, a decontextualization issue. We will see it in the example in a minute. Okay. So basically, the flow proposed in this work is to first generate using some existing method. So it will just plug in some existing generation method that might optionally have attribution or not. We'll see how this impacts the method. And then we allow the user to give this query, okay, highlight, yeah, I want to know, where this fact is supported in the source. That will be that we call the LACER. LACER is localized attribution queries. And here we try to give the information, yeah, that this is a supporting information in the source. So let's go step by step quickly, because this keeps running. The generation is, as we said, just generation and with optional attribution, okay? So we might employ ALK, or we might employ a method that doesn't give any attribution, or we might employ attribute first, okay, or any other attribution method. What happens in LACER? So the user would say, okay, I want to know, well, this relies on the source. They deserve to know what they are eating, okay? And eventually get this output. That's what I would like to know. So what happens within LACER? First, we need to decontextualize the query, because if you let the user mark or indicate a fact, facts in a discourse, in a complete text, are contextualized, what's called contextualized. There is a task, what has been contextualized? In order to understand them, you need to read also the context, right? In order to understand what they deserve to know what they are eating means, you need to look at the context to understand who are they, right? And see that they are the consumers. And that's a general property that when you look at a localized piece of text, a piece in a text, sometimes its meaning cannot be understood without reading the context. That means that this is contextualized information. And there is a classical task, I think like 20 years ago, that of sentence decontextualization. Who knows about like the task of sentence decontextualization? Not many. So yeah, I mean, it's a summer school, so I take the time also to share some information from the literature. So the task is take a sentence out of a document, and if you just read it on its own, you may not understand because it might be a they, and change it such that it will be standalone. That's called sentence decontextualization. And what we would like to do here is kind of fact decontextualization. We want to decontextualize not just even a full sentence, but maybe just a fragment of a sentence to be standalone. So that's the first step. So we decontextualize, and in this step we replace the they with consumers. So now actually our query becomes consumers deserve to know what they are eating, okay? And then we do a search, an LLM-based kind of search that asks where this information appears in the source, and then the LLM, an LLM call brings us back the information, okay? Brings us back the information, and as you see, because we added consumers to the query, even though the user didn't highlight, the user only highlighted the they, now it brings us also the consumers, which also in the source appears not exactly in the same sentence, okay? And one issue here, when we do that, if we use just a method that doesn't give any attribution, when we apply the query attribution, we ask the model, okay, here is a query, where is it supporting the source? If the generation method didn't give any attribution, we just send the LLM prompt to search in the entire document. If the generation method like ALK told us, yeah, this sentence is in a single document, we'll only point the query to search in that document. And if we applied attribute first, we'll only point the model to search for the evidence for within the attributions already, localized attributions already provided by attribute first, okay? So there's kind of a trade-off. So this is basically how it works. In modeling, yeah, so we tested, I'll skip some of information here. We tested a few models here, and also the queries, we both tried an LLM prompt and also another attribution, attribution method that relies on internal representations. You can skip that. And the main results were that when we just focus on a single fact, the citations are on average like 60% shorter. LLM prompt did best this LACER query, better than the other method. When the query had to search only narrow spans in the source, like the output of attribute first, it gave even shorter citations that would be expected. However, that was in the price of lower coverage. So if attribute first in the first place missed some supporting information, then LACER doesn't have a chance to fetch it, okay? So there's actually, the whole issue of localization has some trade-off. I want to be maximally localized, but if I miss something, that I'm missing my coverage. So there's a trade-off, how long you want your solutions to be in the price of the number of times in which we actually get full coverage. I mean, if a human would do that, they could point precisely, but LLMs or technology, have this trade-off. Okay. So to summarize, what we would like actually, putting these two words together, we'd like to actually separately each text within an output sentence, and we would like to provide the minimally kind of needed, which is maximally localized, supporting information. Okay, so this is about localized attribution. Okay. Now I want to make the next step and talk about and suggest that actually these two tasks of hallucination detection and the attribution should be viewed as a single task, a unified task that kind of does both together. And as said here, it means that it should do it as kind of an entailment decay, as a localized. Oops. Yeah. Well, that 2 bottles means one will be sparkling and one not. So that's fine. I hope I won't hiccup. Okay. So let's proceed. So why unified? So if you look at users, right, as I mentioned it up front, right, you need both to verify the correct information, and what you can't verify means it's hallucinated. And in a sense, these are kind of two sides of the same entailment coin. I remind people who knows about entailment, NLI, how the task is defined. Maybe just raise your hands. Okay, so not everybody. This is another very important thing. So, I mean, you really must know. I mean, nowadays, what NLI and entailment, these are kind of synonymous. This is something everyone doing NLP should know. Okay, it's really very prominent. Every LLM is trained on that. Maybe I'll first go to the next slide. So what is entailment? Okay, and this is the work that follows that. This is the paper now on archive that we're working on. So what is entailment? Entailment is an abstraction of a very basic task in inference over text, in natural language understanding in general. Basically, it says, okay, we have some premise, which is like in fact checking would be the source text, okay? And we have some claim, which is called hypothesis. So in entailment terms, this comes actually from logic. Entailment already in semantics, in logic in general, not just natural language logic, in logic, there's this entailment in science comes from logic, means that, if a premise is correct, then the hypothesis, if the premise entails the hypothesis, means that if the premise is correct, then the hypothesis must be correct. Okay, if this is true, then this must be true. This is the entailment relation. Okay, if the entailment relation holds, okay, between two texts, and the terminology, the classical terminology in semantics is premise for the entailing text and hypothesis for the text that is checked whether it's entailed or not from the premise. Okay, like this is what you know, it's a premise, and this is what you want to check if it follows the premise. If it's not entailed, there are two options. One, that there would be a contradiction, actually, right? I mean, like this statement, if you read the premise, you know that this statement is false, right? While it might be that the premise neither contains nor contradicts the hypothesis, and then it's called neutral in entailment terms, okay? Just in fact-checking literature, every task, we change the terminology, but maybe it's more natural terminology. Like every concept is invented in science a few times, so every term is reinvented, recoined in science a few times. That's why you have entailment and NLI for some historical reasons. So the premise will be the source in fact-checking, and the output or the claim to be checked is the hypothesis, okay, in entailment terms. And entail contradicts neutral is called in fact-checking terms supports, refutes, or unknown, right? You can see it's just synonymous. Okay. And if we go back to our hallucinations and attributions, right? If we found entailing evidence in the premise, we know it's not hallucination, right? It entails, right? Otherwise, we know it's not entailed, right? And the two cases of something being an hallucination can be either it's contradicted by the source, or it's neutral relative to the source, right? So these are the two hallucination cases. So you can see that actually these are exactly what I meant. It's two sides of the entailment coin, right? These are hallucinations, right? These are non-hallucinations. And the way to know it is by searching for the evidence. If you find entailing evidence, you know it's hallucination. If you didn't find, either whether because you find contradicting evidence or you didn't find any evidence, then it's a hallucination, okay? That's why we see that actually this entailment perspective gives us both, if we do entailment, we know exactly both the hallucination detection as well as the attribution, because we know what entails or not entails or contradicts the premise, the hypothesis, the claim, okay? So understanding that this is actually what's going on here behind the scenes, all right, or at the basic layer, how should we do such a process that decides whether a hypothesis or a claim is entailed or not by the premise or the source, okay? So, as we've seen, a text consists of multiple claims, right? We've seen that before, like with fact score, the QA approach, right? And each individual claim within the text, the full text, may be entailed or not, right? May be faithful or a hallucination. So we would like to first decompose the source to subclaims, okay? Then we would like to take each subclaim, whether it's entailed, contradicted, or no evidence, okay? And then we can say, okay, if everything was entailed, then the entire hypothesis, entire output is faithful. Otherwise, you know, it's not supported, okay, it's unfaithful, and we can point exactly, and this process also let us know exactly which claims are the correct ones and which are the wrong ones, okay. So I hope you see by now that this actually process unifies what I was telling before. It unifies both the attributions as well as the hallucination detection, right? You get both outputs out of this process, okay. So let's see some examples, and then so we're actually tracing the entailment reasoning or providing justifications for this entailment reasoning. This gives us as an output both the hallucinations and the attributions in a localized manner. Okay. So just let's see how it looks like. You can see here, this is like a hypothesis, a claim about a shuttle service. You can see this is the hypothesis. It actually can be decomposed to three different claims. So like fact score may take out these three parts, okay, which are highlighted here just to show where they are appearing in source. And then for each of them, you try to find SH is like the statement or the claim in the hypothesis. SP is the corresponding claim in the premise, okay, SH, SP, the subclaims in the hypothesis and in the premise. So because all these are entailed, these are the claims actually in the premise, in the leftmost column, right? This aligns with this, and this aligns with this, okay? So these are the statements that support each of these statements, okay? Since all of them are supported in this case, it's entailed. The entire hypothesis is entailed, right? In this other example, you know, one statement is entailed by this, one statement is actually contradicted by this, and the other is neutral. And there is some contextual text what is the evidence for neutral? That's a tricky question, open question, so I'm waving hands here, okay? But there is a little bit of work. I mean, if someone is interested, you know, that could be a great topic for a paper, how to attribute neutral or unknown evidence. Sometimes you just can't, but sometimes you can, so it's a tricky issue. But one is entailed, one is contradicted, one is neutral, so the overall conclusion is contradiction, right? If there's at least one contradiction, then the entire output is contradicted. It's definitely false as a whole, given the premise. And here there's two entailments and only one neutral, so no contradiction, so the overall judgment is neutral. Okay? So this is how this reasoning and these justifications look like. I have until
50, I think still 50 minutes.
50 minutes. Okay. Okay, and as we mentioned, this can be used just like the use cases of hallucinations and attributions. These apply also here because it's unified. And notice that this setup is, again, it's the entailment just abstracts the situation that you want to check whether something is entailed or is implied from something else. So the whole space of hallucination detection, attribution, fact checking, it might be, you know, fact stated by a politician that you want to check against some records, it goes back to the entailment, to the textual entailment or NLI setup, where you want to test a textual claim or hypothesis against some textual premise that you assume to be correct. You assume that the output of the claim should follow. Okay? So this setting is extremely generic. That's why if you don't know what NLI or entailment is, look at it. Okay? Complete your knowledge. This is really a must in NLP, not just because we started this line. I mean, there are tons of citations not for our work, for lots of work in this space. Okay, so this is what we would like to get. Okay, this kind of reasoning or justifications. And the first work that is kind of ongoing now, we have a first version already in the archive. The link is there. Is about trying to check if we follow this kind of reasoning that combines both the hallucination detection and attribution, would it improve the bottom line performance of hallucination detection? So we have, let's say, some data set in which people took the sources or the evidences and the LLM output, and they annotated manually for each sentence in the output whether it's correct or not based on the evidence. So we have such data sets. And what people do, they apply some NLI or entailment models to check for each, and that's how you try to see, and then they see whether they match the gold annotation. Okay, so our research question is to see, okay, if we let and what happens when people do that? Either the user is a bunch of fine-tuned models, for instance, mini-check-like is one of the recent models that works well, that are fine-tuned on such entailment data or hallucination detection data, and they were fine-tuned to tell which outputs are wrong. Okay, or in many cases, people just prompt LLMs. Okay, when they prompt LLMs, and often they do that because it's easily accessible, it's not domain specific, you do it in any language. LLMs are so generic, and performance is similar with dedicated fine-tuned small models or just calling a strong LLM. So what we wanted to check is first, if you use the second method of LLM prompting, how well do they do? I mean, we've now seen how correct entailment reasoning should look like. Do they manage to do that? Okay. And second is, if we guide them, what if we tell them the story from the previous slide? We tell them, this is how you should reason about entailment. Will their bottom line performance improve? Okay. So these were the two research questions in this project. And how did we do it? So first, just to understand the motivation. So if you look at the literature, when we did, you see that when people use LLM for NLI, they kind of, rely on the LLM's interpretation of terms like consistent. You see, is this consistent? Is it supported? Is it a hallucination? Okay, or is it entailed? Is it implied? No, various kinds of paraphrases. Basically relying on the fact that LLMs knows these concepts of entailment in a sense. Which, by the way, they do to a large extent because they are typically in training process of LLMs, entailment data sets are included, okay, at various stages. And sometimes, like here, they ask a model to do a chain of thought. Chain of thought, who knows what chain of thought is? Chain of thought is asking the model to explain, we can tell the model like here, is a sentence supported? Answer yes, no. Or in a chain of thought, we ask the model, please explain how you reach your conclusion. We can ask a question to a model and say, okay, give us a chain of thought, how you go to the answer, right? If it's a mathematical question like, right, John had 3 apples, he gave 2 to Dan, etc., the model would then explain how they did the math reasoning. That's called chain of thought, asking the model to explain its own reasoning, to explicate, to verbalize in the output its own reasoning. Okay, so some prompts ask you, so first explain your thoughts. They do. Let's think step by step. It's a common prompt also. There are, again, some paraphrases that guide models to explicate a reasoning process. Okay, so that's what people typically do, and it's not very principled. Okay, so what we suggested, and technically from implementation perspective, it's changing the prompt, but it's not just prompt engineering. It's actually trying to see what happens if we guide the model to do entailment reasoning in the right way. Okay, so we have devised the prompt. This is just, you see there are many 3 dots. It's not the full prompt, but actually first decompose, then try to simultaneously make the attribution entailment decision. There is some explanation, right? If you find it's entailed, or then otherwise check if it's contradicted. If you didn't find either, then it's neutral. And then you do the final decision. If everything is entailed, it's entailment. Otherwise, it's not entailed. Okay. So basically, the prompt tells the model to do this process that we've seen before. And this is how it looks like. You see, like in an example, you see, so the model did like decompose it into two parts, and there might be better decomposition. So that's another line of research, how to guide models to do the right decomposition level for entailment. And it's two facts, check each of them. The first it said isn't directly addressed, the friend is definitely supported. And then the bottom line, one of them is not addressed, so the bottom line answer is not. Okay, so that's basically how the method looks like. And then what happens when and the baseline we use is a chain of thought. You just let the model think step by step. Okay, and when the model thinks step by step, often they do some localization, some decomposition. You ask the model why this isn't there. Explain why, how you go to the conclusion. It might on its own say, yeah, the first part is here and the second part is there, or the second part is not here or contradicted. It will do something in that flavor, but of course, as we see, when you have the baseline or you explicitly guide it, there are substantial improvements. Okay, so models on their own don't know how to do properly this kind of entailment reasoning. And then, so that was like a positive answer to our research question. Yeah, that if we indeed guide models how to do entailment reasoning, they can improve. And on their own, they do it less well. Not bad, but less well. But then we wanted to ask, okay, what happens when we guide or not guide the process? How correct is the reasoning process? We've seen here bottom line improvements, but maybe the model performs better, but actually along the reasoning process, it doesn't work that well. So for that, we devised some measures. So we were actually, in this work, we tried to tackle the question that was not addressed before. How do you evaluate the validity of the entailment reasoning process all along? Okay. And we've come up with the following measures, right? Because we have decomposition, attribution and entailment decision, and then aggregation. So decomposition, you can check how much it was decomposed to two facts, three facts, etc. When you decompose, each fact that you extract should be entailed from the hypothesis, right? Like if you decompose a sentence, each fact should follow from that sentence, right? You cannot decompose two facts that are not in the sentence you're decomposing. And complete. If you decompose, let's say, a sentence to 5 facts, you need that the union of these 5 facts, conjunction of these 5 facts, would be identical to the original meaning of the sentence, right? So these are for the decomposition facts. Attribution entailment, how many of the subclaims have correct attribution, for how many of the subclaims entailment decision was correct, and aggregation, did you aggregate correctly? Model might error also, says, yeah, this was a contradiction, but the bottom line says, yeah, it entails, even though along the way it says contradicted. Okay, and here we see an evaluation of that. Okay, it's small scale, as the first bullets show, but the main results are that first, indeed, when you instruct the model to decompose, it decomposes more. This is an explicit method, decomp score, that tries to decompose to a maximal extent, or to a fairly maximal extent. Again, not as the Neo-Davidson, but you see that this indeed gets more facts, but it's not clear what's the right resolution for entailment purposes. There's still interesting work there. And as you can see here also, soundness and completeness are fine. So models are pretty good at decomposing a sentence into facts where each fact is indeed embedded in the sentence that is decomposed, and together all facts are quite good in covering the original sentence. So they're quite good in decomposition. With respect to attribution, you see that models of their own, just through their own chain of thought, they give attributions, but in far less percentage when they are instructed. When instructed, they provide good attribution in most cases. And for entailment decisions, given that they found a good attribution, they also usually quite highly correct with making the right entailment decision. And again, when instructed to do that and getting better attributions, they also improve in the entailment decision. And aggregations, they're good. If they said along the way it's contradicted, they won't say at the end it's entailed. Okay. So what we can see here, So I can skip. So the bottom line is it's important if you want a model to do some task, in this case entailment, particularly entailment, I assume this methodology would be relevant for other cases. And now we have these reasoning models, everyone knows heard about reasoning models, right? R1, etc., DeepSeek. This Gwen model is also a reasoning model. So we should start looking at, how to guide them to do the proper reasoning. We cannot always trust them, and also to figure out for a certain task how do you evaluate the reasoning process? I mean, these are things that haven't been attempted much yet. Okay, so this is and the use cases are the same use cases as for the previous case. I wonder if I just, because I have 5 minutes, maybe I just tell you, I think I'll kind of, I mean, the last part is more about a novel thing, I mean, a line of research in initial stages. I just tell the general kind of message, maybe here. Oh, maybe okay, I'll just summarize from the title slides. No, I mean, I'll two different sub-projects here. I mean, so all along I've said that, right, motivation for doing the localization, doing the proper reasoning is because this will be good for users, right, for us. And it was quite intuitive. I mean, everybody was nodding, thanks. So it's quite intuitive, but we should actually check. In most projects, we don't check how it actually affects users, okay? And the line of I would like to advocate is that actually we should do tests with users. So here is some work. I suggest you to look at it, see et al. You know, it's called Large Language Help Humans Verify Truthfulness, except when they are convincingly wrong, okay? But they actually did test, okay, when we show the output of an LLM to users, how many times they get the right decision or not. And there are interesting outcomes. And what we suggest is, okay, if you want to measure the impact of users, why should users only see, let's say, the reasoning output or justification at the end? Maybe along the way they can be involved. Maybe it's more interactive. What happens if attribution is incorrect? What does the user do? I mean, they need to search, maybe see additional things. Okay, and here I just show the kind of the motivation. And another line of research we're working on, I won't have time to give hints, but again, it was only a mock-up, so I'll skip it. I mean, it will be on the slides. We're talking about generation processes, and they do hallucinate. And people nowadays use LLMs for writing. But as everyone knows, writing with an LLM is pretty much an art these days, right? I think we can think of it as kind of as a co-writing, right? As a collaborative authoring process. I'm just showing the title slide, where humans and LLMs work together, and then understanding what things the user can do along the process in earlier stages, not just waiting for the final output, and do something in a more collaborative manner, such that the overall output of humans and LLMs, eventually, if we write a document with an LLM, we sign on it, right? So it needs to be a collaborative process, and how to do that, it's completely, I think, a very important direction, and hardly investigated little work, but I promote this direction, and by that I'll conclude. Maybe I'll just put up my conclusion slides, should it be up. You can see here's some mock-ups. These are the takeouts I want to offer, and maybe we should give a couple of minutes for questions. Okay, thanks for listening.
So we'll have time for questions.
Yeah.
So my first question was like, what you were saying. Yeah, in one work you were showing like because the summary will be generated, then you will kind of localize through multiple.
So, sorry, I don't hear you that well. Maybe can you get closer? Or maybe you can see it. Okay, sorry, I didn't want to. Okay, just no. It's so everyone.
Yeah, in one of your work, you're saying you'll first summarize. You'll have the response based on some documents, and then you localize some of the components from the output answer or the generation.
Yeah.
Right. Like if the generation itself is factually wrong, and
If the generation is wrong?
Generation itself is factually wrong, and in like let's say whatever the things you want to kind of attribute, and that attribution doesn't exist in the kind of whatever the context documents you have. What do you do then?
Yeah, it's a very good question. It's related. I hinted, right? I mean, we know that hallucination can be either a contradiction, so there is something in the source that contradicts the hallucination,
yeah.
Or it could be neutral or unknown in the sense that it just invents something. It's called in the hallucination literature, it's also called extrinsic hallucination, like it brings something out of the blue that's not in the source. So if something is like, if the model just completely invented the fact, then there is no attribution in the evidence, right, in the source. And this is actually a difficult issue because it's like retrieval of documents, right? How did you know that you got all the relevant documents? You have to search the entire collection. You know, if in fact, to know that something is really hallucinated, not supported at all, not contradicted, you need to go over all the sources. And if you're doing like multi-document summarization, you bring 100 documents from which you summarize, it's hard. So this is quite tricky. In some sense, the right answer would be to exhaustively go through the entire source and verify that nothing entails or contradicts. That's very hard. So in these cases, often there's no attribution, and I don't think there's a good answer. Again, I think it's great things to investigate. Sometimes some pieces in the source do say something different, and you can understand that the model confused something. Like in the, died of measles, where he died, but it wasn't clear if it was measles or not. Okay, so then you can see it's in that case it was actually a contradiction. But hallucinations, if it's not entailed, neither entailed nor contradicted, is a tricky issue, and I don't have a good answer for that yet.
No, so what happens if it just contradicts? Like,
if it contradicts, then you have the contradicting evidence, right? Because like if for instance
no, my question was, you are highlighting, let's say, the supporting phrases or sentences in that work, right?
Or both the supporting as well as the contradicting.
Okay.
No. So also for the contradicting,
Okay.
contradiction is actually easy. Contradiction is like entailing the negation. That's contradiction, basically. Okay. Contradiction is just here. The contradiction. We just entailing. So this entails it. Like this says 5 people died, and here it's 3 people died. So it contradicts. Okay.
So this one more question because of the time.
Okay.
So what if the entailment itself is hallucinated?
So I mean that's always.
Because when we are dealing with numbers, the entailment can be hallucinated also. If it is
might be wrong.
It's fine.
Yeah, entailment certificate might be wrong, right? So I mean that's what I'm suggesting. That's why I'm advocating also what happens? Okay, I mean we rely on AI, we rely on systems, right? AI these days. Okay, they may be wrong. What do you do? I mean it's a hard problem. That's why I advocate the interactive setting to investigate. How can users recover from AI errors? That's a very interesting research direction. And again, I don't have a good answer. No one has.
All right. Given the interest of time, and let's thank our speaker again, and then Ido will be with us all the time. And then please reach out to
Until tomorrow at the end. Okay.
Yeah.
Thank you.